Good morning. Today we are having an interesting and a little tricky case. Here is a 70-year-old female presented with non-ST elevation myocardial infarction, and angiogram we are going to show you in short. She is also a known case of chronic bronchitis with the diabetes and the hypertension as the comorbid conditions, and her renal functions were normal. Syntax score 27. So this is the angiogram. So we can see in LAO cranial there is a critical ostial left main aorta ostial lesion stenosis, and in RAO caudal, apart from that left main lesion, there is no significant lesions were noted. So with the syntax score of 27 less than 33, and this is the aorta you can see in this particular view. This is a clear porcelain aorta. So surgeons were a little bit hesitant to operate on this case, and we can see even bronchus is hugely calcified, and RC is a non-dominant, very small, diffusely diseased vessel. So there is a critical aorto-ostial left main stenosis with syntax score of less than 33 with the calcified porcelain aorta. So we decided to go ahead with the PCI with some calcium modification. And the device we are going to use for this particular calcified lesion is the intravascular lithotripsy. Over to Dr. Ajit.
So you can see the critical left main, and there's a lot of calcium even on the fluoro. But we will now do the next steps. So what we've done next is used a 2 mm balloon to pre-dilate the whole thing for the IVUS transmission. So we can see that the balloon has some base, but it comes up at high pressure. And now we will show you live the intravascular ultrasound, after which we'll decide what we are next going to do.
So in the LAD, proximal LAD, the diagonal joints, no plugs, some eccentric plugs in the left main. And as we are coming close, we can see clearly the vessel size is also not big. So here maybe in the shaft, if I measure the vessel size, it's 5.5 millimeter cross 5. So approximately 5.25 average size. Whereas as I'm coming towards the ostium,
Just hold this from here. Just hold this.
I can see one EM at 12 o'clock here, and here another EM. So it is only 3.9 in vertical axis, and here actually I should not measure because it is aorto-ostium. Maybe I'm continuing the EM as a imaginary line and I'm measuring. So it's going to be around 4 at the aorta-ostium. Though it is 4.
So the first issue, do I need IVL or not? The answer may be yes. We could possibly get away with no IVL, but I plan to use the IVL here. The next issue is what diameter. As Dr. Nandakumar said, it's the contact, it is at about 2.7, 2.8. Is that Nanda?
2.5 is the lumen size, where the vessel size is 4.
So I think a 3.5 would be a reasonable amount, because I think the left main, once it opens up, is going to be pretty large, and it's going to be at least close to a 4. So I think I'm going to open up a 3.5 IVL balloon. So can we get that IVL balloon ready, please, now? Yeah. And what we're going to do now is quickly get the 3.5 coronary IVL shockwave lithotripsy balloon down into the left main. And then once we are at the site, we will inflate. There is no trouble in keeping 2 wires when we're doing an IVL. That's a good part of the whole story. I hope this IVL catheter will track down the left main. We had not much difficulty in the left main with the... So here is the catheter coming, and I think we are through. So we are across. The pressure is okay. Small check, please. Okay. So I think we are across the left main. I'll reduce the pressure on the catheter. We're releasing the guide. And now I will go up with the balloon at 4 atmospheres. And then, Ram, when I tell you, we can start the pulses. So let me just first go up with the balloon.
Sir, can you deflate for some time, sir?
Yeah, so the push button has to be pressed on the side. So we've just got the pressure down a bit as the patient had a little bit of hypertension.
We'll pull back the balloon For some
Yeah,
time.
it's having a good drink.
Okay,
No
now its
problem.
pressures are improving.
There's a little bit of a disconnect there. So we're going to do that. So this, yeah, so we need to now go up again. And
Yeah.
we are up to 4 now. Press,
Sir,
please,
you?
continuously.
Yeah.
You can hear the noise now of the pulse, and you can see the pressure pulse there. Continue the pressure. And we saw the pressure fall. So we have deflated it. Now I'm going to inflate it again at 4. So we had 5 pulses, and now we go up again.
Deflates, sir.
Okay. Okay, so this was done. The first round is over. So let's see how it happens. The next round we'll do the full 10, please, because let's hope that he can tolerate the pressure as well. Okay, let's take a small shot here. So we're getting to the next round, and now we are at 4, and
Yeah,
now you
press.
press 3, 4, 5, 6, 7, 8,
9,
10.
10. Okay. Yeah.
We
Pressure
have to wait
dropping,
a
sir.
little bit
Deflates,
of a
sir.
second, and we deflate. Okay. So now I'm going to change the direction of the catheter. Okay, a little
That's
bit
okay.
further. Okay, that's good. Okay, now we're going to go up again. Okay, so I'm going to go up full again to, so we'll give the entire 10 cycle this time again. So we are at 4 now. Okay, go ahead.
Starting.
On.
1, 2, 3.
And the shockwave
4,
pulses are not capturing
5,
the heart. We can see
6,
clearly there is a dissociation
7,
between the shockwave
8,
pulses and the arterial
9,
pressure tracings.
10.
Deflate, sir.
Okay, so we've done something with the IVL now. I'm letting the balloon deflate. The pressure came down, and I will just bring the balloon back. Let the pressure come up, and we'll do an IVUS now. Okay, and for the viewers, as
So
to
this
what
is
we
the aorta ostial 180-degree calcium, the arc, and this the left side of the screen is the aorta, and right side is the left main wall. As we move in, the calcium is only limited from 4 o'clock to 7 o'clock position. And here maybe we can say some micro dissections, some tracks are seen here, some 2 tracks. Apart from that,
IVL.
we don't expect anything also. It's just to spongify the calcium and to expand the stent in a better way. And fluoroscopically, we have seen clear expansion of the IVL balloon. Here, if you see the size, the minor axis it is 2.8, in the major axis it is 4.2. So 4.25, somewhere 3.75 to 4 is the distal size. And ostium, as we already discussed, it's little negatively remodeled area. So maybe this portion of the ostial left main we can take for sizing. It's again for, I think 4 is the diameter of the stent we are going to take, and we need to come up to this ostial portion.
Yeah, so what we could do is basically take a 12 and maybe keep 1 millimeter out, or maybe take
Even 2-3 millimeters out, it is going to land
is
inside
fine.
the
So
left.
I think basically what I will do is take a 412 and deploy that at nominal pressure, because with an IVL, usually the vessel is spongified and open. So we need a 412. Can we get an Onyx or a Synergy stent, please? Now I use this second wire, and you can see there are 2 wires here. One is a extra support wire just to help the tracking, and the other is a floppy wire for tracking all the catheters in. So basically, we used 2 wires in this area, and you saw that even with the 2 wires, the IVL had difficulty in moving through that lesion. So we need to have extra support wires always for IVL. I always use that. I would suggest every operator to use a strong wire, especially when we don't have guide support like this patient, where your guide is loose in the left, in the aorta. Bring it a millimeter back and go to the RAO caudal. Now I think we're just at the ostium. The pressures are good.
RAO
Come to the
caudal.
RAO caudal, please. Just to be sure we have not crossed the bifurcation. Take a cine.
Yeah.
So we have crossed
Yeah.
that bifurcation,
Yeah.
so we need to come back.
Come back.
So we'll be very careful here that we are not across the bifurcation. So we are just
Yeah.
at the bifurcation. Maybe pull back a
Yeah.
millimeter.
Maybe one.
We'll check in elevocranial once again.
We'll go to the eleocranial. What
This
do you
looks
think?
okay.
That's perfect?
Yeah.
Okay, let's go up there now. Go up
Chalo.
slowly. 2, 4,
2, 4,
5,
5,
6,
6,
7,
7,
Oh,
8,
it's
9,
9,
10,
10,
11.
11,
Nominal at 12. Yeah.
12.
Deflate.
Deflate.
so I think the stent moved a little back during the
Yeah.
inflation into the left main ostium.
The stent did move a bit, but I think that's expected because I was pushing the balloon, but it still moved a bit back. But there's no disease at the bifurcation, so it's okay. So I'm just going to go up a bit again here. Go up here.
Yeah.
Yeah. 12 again.
3, 4, 5, 6, 7, 8, 9, 10,
11, 12. Deflate.
Deflate.
We will do a IVUS, then we will take a call for post dilatation.
It's a bit underdone. We need to do some work there.
Yeah, we will first do with the 4O NC
Yeah.
balloon, then we will take IVUS.
Give me a photo NC, please. Keep this wire out.
Maybe short
4 NC,
8,
short 6.
6, something like
6
that.
or 8. Yeah.
Actually, it didn't move much back. It looks
It's
exactly
all
at the
right, but I
ostium
think we
only.
only have to be careful when we get the balloon across that we don't hit the top of the stent. So you can see the difficulty because of the eccentric landing of the stent. I'm just inching my way through very, very slowly. Okay,
Yeah, I think
it's very important not to disturb the ostium or disturb the. So we are now distal
Yeah.
area. We're just slowly getting that down. Okay, I'm going to do a cine to see whether we are inside the stent.
Yeah.
Difficult to make out, but come to the RDO caudal. And I need the stent boost here, please. Please get a stent boost down.
Yeah. We are outside.
We are outside the stent, so we need to come back. And you can see that it is. Okay, now go up. 8, 10, 12, 14,
Yeah,
16,
going up.
18, 20.
8, 10, 12, 14,
16,
16,
18, 20.
18, 20.
Hold it there.
Yeah, 20 holding.
Then I come back and pull the guiding out. Go up there, please, again, 20. 20.
Yeah.
Go up, 20.
18, 16, 20,
18, 20.
20.
And hold it there.
Yeah.
Deflating.
Deep.
And now we're going to flare it at the ostium. Go up there.
Going
Flare.
up. Yeah.
20,
20,
22,
22,
24.
24.
Yeah, deflate. Flare 22, 24.
Going up. 20, 22, 24.
Deflate.
Deep.
Flare 22, 24.
Going up. 20, 22, 24.
Deflate. So she's tolerated that reasonably. So hopefully this has done the trick. And we try to get an IVUS now and see what you've done. So we went up to 24 with a photo. So I think we have got a reasonable, it's a guiding is inside, but we'll take the IVUS and see it. But the guiding is not really compromising anything. So we'll get down the IVUS and then pull the guiding out and check the whole stent. The issue is whether we need, so 4.0 at 24 is how much, sister, please? What is the size at 4.0 24, please? 4.3. Okay, so
Yeah, the stent is starting, and it is well opposed. Now here there is some mole opposition. We know there this is the area of 5 or 5.5 millimeter, the minimal mole opposition. Again, as we are coming towards ostium, it is well expanded. We can see the oval expansion. That is why in that particular view it is seen as a, and there are a little bit stent protrusion into the left main. We will measure how much it is protruded. I'm stopping here.
so
So the
from
first thing, distal edge, it is clean, no edge dissection, well expanded. Then I'm going to see the malopose area measurements. It's 530 microns. Maybe we can go with the 5 millimeter short balloon only in the middle portion, not at the distal edge, not at the proximal edge, just in the shaft of the left main. And the malopposition length is, so the length of the malopposition is 3.2 millimeter. Definitely we need to address it more than 3 millimeter. What are you asking,
no,
sir?
I'm asking you the lumen area
Okay,
at the
the
side.
MSA at the ostial left main, I hope it is going to be 11, 12, or even more than this. So it's 14.
Okay.
And the length of the stent which is extending into the left main, (4 millimeter) into the left main. So we are having a pot PTCA balloon at
No,
5.6.
I would rather have a routine 5. I want a little taper on the 5. Yeah. The pot has no taper. And the problem is, yeah, when you go through this stent in the ostium, you got to be very careful that you don't distort the stent. The pot stent, the pot balloon has no shoulders. Very good for, let me just have a routine 5. What are we giving us?
5
NC
milli.
quantum? Okay, that's fine. Yeah. You need to be very careful as you go in that we don't distort any part of the stent. And that's the key here.
Even if we are coming out into the left main, no problem, but we should not go at the distal edge. At least we have to 3 millimeter away from the distal edge.
Can I know how much away are we from the bifurcation, the stent? Is it a millimeter or more?
So this is the figure of 8 polygon of confluence, and this is the distal edge. (3.79 millimeter) is
Away.
the
So maybe we
distance.
could have pushed a bit.
The same that 3.7 actually came into the left main.
Yeah. So if we had pushed in a bit the stent, maybe it would have been okay. But as you saw, as we deployed the stent moved back. And I think the reason is because as the stent straightens and at an acute curve, the stent will move back. And though I was putting pressure, it would do that. But anyway, let's go to the LAO caudal, please, again. LAO caudal, please. So I'm floating the guiding. We should not have it anywhere near the stent.
Another interesting thing is the length of the stent in the IVUS is exactly 12. So it
Yeah.
neither elongate nor shortens after deployment and post dilatation.
Yeah.
Okay, so we're
Go
now
ahead.
through. Then now you re-engage the balloon. So what we are now in the stent, go back to the PA cranial. So now we need to go a bit distal. I'm just going gentle pressure with the balloon. And I just want to go to the RAO caudal now. We take a shot. So we are away from the bifurcation. Yes,
Yeah,
we are
we are
away
away.
from the bifurcation. We are within the stent and we go up. Yeah.
So going up with your 5 millimeter balloon,
Just go to
6,
nominal,
7,
please.
8,
9,
10,
10.
10, 12.
So that's a 5 deflate.
Deflate.
Go up here, please.
5, 12.
And we flare it now. Go up, please. IVUS ready? Can we get
So
some dimensions now?
it's 14 millimeter square is the distal reference. And this is the area of mole opposition. There is no mole opposition. We can clearly see everywhere it is well opposed stent. And this is the aorta ostium, that oval expansion area. And these are all artifacts. Stents looks as if it is vertically positioned. Actually, these are artifacts, which is commonly seen at the LM ostium. So it is 14.36 compared to 13.98. It is more than 100% expansion at the ostium. So very well expanded stent, no mole opposition, no distal edge dissection. And we can see here the LCX and LAD is clean of any dissection and block sighting we are done.
Okay, so all you can see all the branches there. The LAD is flowing freely. Show me the previous two pictures.